Hello, today I'm going to show you the step-by-step of proving the sine rule. Okay, what is the sine rule here? The sine rule says that if I have sine A over A should be equal to sine B over B, which is equals to sine C over what? C. The inverse also works, means that A over sine A will also be equals to B over sine B to be equals to C over sine C. How do you get this? As usual, the diagram is not drawn to scale, okay? So I have my triangle. This triangle, I'm going to form right angle triangle from it, which is, so let me name this side D. Let me name here A, B, C. As you know, if here is A, the angle formed there is A, the angle formed here is B, the angle formed here is C. If here is B, it means that the length will be B here, the length will be A, and from here to here, the length is what? C. Is that okay? Good. Now, this is the height of it. So, this is our beautiful diagram. Now, if I take sine A from this triangle, that is when I'm considering triangle ACD. I want to consider triangle ACD. That means sine A will be opposite over the hypotenuse. So, opposite is what? H. Hypotenuse is B. Let me make H the subject. Simply dividing here by 1, doing cross multiplication, which will make H to be B sine A. Is that okay? Let's name it equation 1. Let's also consider triangle BCD. Okay. So where is our BCD? Our BCD will be, if I take sine B is going to be opposites, which is also H. Hypotenuse is A. Means that my H will be A sine B. Is that okay? Let's name this one equation 2. Now, let me divide it like this. We can say that H is equals to H, because they are all possessing one height. So what it means is that my H is equals to what? H. So the first H from equation 1 is B sine A, and the second one is A sine B. Now let me divide through by AB. So this B goes with this one, leaving sine A over A equals sine B over B. Now, you see, we are able to achieve this and that. Let's with this one. So let's see what we can do. With the same diagram, you can decide to redraw this diagram again, okay? Let's see. Let me redraw it, because if I do the other way around, it will be some way. So let me redraw this diagram. Then, here I'm going to change the positions. Let me bring the C here, A here, then the B there. What it means is that, so I'll be having my height here, which is H. Let me name here D. From here to here will be B, right? The length will be B. Here is A, here is C, here is B. Here will be A, here will be C. Is that okay? So the same approach. If I take sine C, that will be H over what? A. So let's see. If I make H the subject here, I'm going to have H to be equals to A sine C. Is that okay? Let's name it equation 3. Then let me take this side again. This side will be sine A, which is going to be H over the hypotenuse, which is C. I'm going to have H equals C sine A, equation 4. Means that h is equals to h, right? Looking at the equations, they are the same. So what we have here is that from equation 2 we have a sine c equals to c sine a. So dividing both sides by ac, ac. See, this a will cancel this a, leaving sine c over c equals to sine a over a. Okay. Now let me ask you this scenario. If I have 1 over 2 to be equals to 2 over 4, and I also have 1 over 2 to be equals to 4 over 8, can I say that 1 over 2 is equals to 2 over 4, which is also equals to 4 over 8? Yes. So we can, though this and this is equal, which is separate or different from this and that, but since 1 over 2 is equals to 2 over 4 and 1 over 2 equals to 4 over 8, it means that 1 over 2 is equals to 2 over 4 and 2 over 4 is also equals to what? 4 over 8. That's the meaning. So this is what we are going to do. So in that, we can conclude that from the first one, the answer we have this one, sine A over A equals to sine B over B, which will be equals to, now sine A over A is also equal to sine C over C. So you can say that sine C over what? C. So this is proved. Thank you for watching.